From within this checkpoint management console, we see a policy with AWS, GCP, and Azure environments, all with the north-south traffic inspection rule applied. Using Cloud Controller objects for an environment can be imported directly into the policy. What truly makes this policy dynamic is the controller's ability to sync any changes from the data center to the object within the management system. From within this data center input window, we can see all the environment's object that the controller syncs into the management console. Any object put in the policy will be automatically updated with any changes such as name or IP addresses with no policy install necessary. This heavily reduces the overhead of upkeep of the cloud-based security policy. In addition to the cloud environment-specific rules, you can also include cloud-agnostic rules, which will apply to multiple different cloud environments at once. This is done through data center query objects, which are based on attributes across multiple data centers. As these data center objects, when the data center query is added to the root base, the CloudGuard controller pulls the assets from all the data centers in the query object and updates the gateway. The query logic here is all assets from type instances or load balances and tagged with server type equals ProApp or ProDB. This allows for a truly cloud-agnostic policy. One rule will apply to any data center that matches the logic. New data centers can automatically match this rule as well. Switching back to CloudGuard Intelligence from the Infinity Portal, the Traffic Explorer analyzes network flow logs to show the cloud security admin a visualized of actual network traffic in the organization cloud environment. It can be used to identify traffic from unwanted sources or gaps in network security settings. We can choose to view the visualization grouped in different ways by effective policy name, VPC, or VNets. Many common queries are included, and admins can create additional custom queries or filter their result. This is much more intuitive and user-friendly experience than sifting through cloud logs. Easily filter and customize the searches to visually see the related traffic in the cloud environment. We can get more in-depth information regarding the malware we have just discovered in Logs tab. The Statistics tab can show abnormalities of traffic trends which should be further investigated. CloudGuard Intelligence has several rule sets based on the MITRE ATT&CK framework that can be set to continually monitor the environment and notify the admin of anomalies. Using machine learning analysis, abnormal traffic is identified and can be visually seen here. CloudGuard and SaaS provide Check Pont security and threat prevention as native cloud firewall integrated into the cloud's network infrastructure. As we indicated in lines 33, 84, 85, and 86 in our survey response, CloudGuard and SaaS will be available on AWS in Q3. This new cloud-native service delivers advanced threat prevention, automated and elastic zero-trust cloud network security, web application, and API protection. The user experience is similar to AWS Network Firewall, but will support multi-clouds and includes threat prevention in addition to Network Firewall. As part of the initial customer's deployment, the AWS CloudFormation template creates the necessary account rules so CloudGuard can access the AWS account. Going back to Check Pont Infinity Portal, we can see the assets from AWS listed. This includes all the VMs, subnets, VPCs, gateway load balancers, and other objects. After this short setup, the systems start learning. The machine learning process takes around 30 minutes, depending on the size of the cloud deployment. The system also tracks the account traffic flows and creates logical network zones. After the learning is completed, the user can see the suggested zones in their environment. The system identified the different VPCs based on labels of the EC2 instances and the relations between them. The system also creates data center object queries based on traffic flows and labels. Zones are defined based on the labels in the relevant VPC and cloud accounts. These are purely identity-based with no IP addresses here. Any native security groups will be imported into the network policy as the network flows that the system uses for the learning already reflect these groups. In the Access Control tab, users can review the suggested policy that was produced by the machine learning process. For each zone, the system automatically creates a set of access rules that the user can review and decide if to use. After the user reviews the results, they can enforce the policy. CloudGuard and SaaS help security engineers to introduce native network security to a fully deployed cloud data center without disrupting operations and with very minimal effort.